What we're going to do in this video is to take a look at a case study for an internet application to provide some very simple functionality for a vet, where the vet might want to view all pets, or to view for a given pet the owner, or for a given owner to view all those owners' pets. This gives us a very simple use case diagram. We can see the use cases here, and we come up with names for the use case by finishing off the sentence, the user wants to use the system to, and then complete the sentence. The user wants to use the system to view all pets. The user wants to use the system to view owner, and then view owner's pets. The extend arrow indicates that the view owner use case will extend view all pets. In other words, we're anticipating that we will get to this use case having first accessed this use case. If we go to the next page, we will see the activity diagrams. There will be one activity diagram for each of the use cases. So in this very simple system, 3 activity diagrams. With the name of each use case at the top here, it helps us to understand exactly which use case is being considered in this activity diagram. This is an indicator to say this is the initial activity, and this shows us where the activities come to an end. It's the final node. The first activity then is to get all pets and then display all pets. For view owner, we're also doing something very straightforward. Get the owner and then display the owner details. For view owner's pets, we're doing something a little more complicated. First, we must get the owner, and then we have to decide whether or not to get the owner's pets based upon whether that owner actually exists. So when we're getting the owner, if the owner is found, then we will get that owner's pets and display the owner's pets. Otherwise, if it's not found, we will do nothing. Having developed the use case diagram and the activity diagrams, if we're following the Unified Software Development Process, USDP, which is what we are doing in this example, we'll then move on to the analysis model. Now in the analysis model, we consider each of the use cases in turn and put into the one diagram the activities described in the activity diagram for that use case. At the same time, we're starting to add in what are known as analysis classes. And there are 3 types of class. A boundary or interface class, which is indicated by this circle with the T on the side of it. Control classes that have the arrow on here, and entity classes which have the line underneath. In an analysis model, there are only these 3 types of classes. And because we're in the analysis model, all we're doing is thinking a little bit about what classes there might be. These analysis classes, when we get to the actual design and the class diagrams, could very well turn out to be many classes. For example, this user interface class, if we're doing this in an MVC environment, will receive and process the incoming requests, which is what a controller does. And it also sends out information back to the user, which is what the view does. And so this boundary class will actually consist of some control components and some view components. Typically, the control classes and the entity classes will appear as model components in an MVC environment. And so what we're saying here is that for the view all pets use case, there will be a message, this is what the arrow indicates, there will be a message called view all pets that comes from the user to the boundary class. The second step will be for the boundary class to send a message to the pet handler class asking for get all pets. That will return the collection that is held in here, and typically that is what these controller classes do in the analysis model. They store and manipulate collections of entity classes. And that collection will be returned to the boundary class, and the boundary class will then call from each of those entity classes, in this case the individual pet, methods to get details. Now what I've done here is, instead of showing all the individual get methods, I've just bundled them up into one generic message called get details. So view all pets will come into the user interface. The user interface will ask the handler to provide all the pets in its collection, and then the user interface will call the get methods from each of the pet objects that was sent back by the handler. A very similar thing is going to happen here with view owner. But when we're looking for view owner pets, we've got a slightly more complicated scenario, because what we're going to have to do is find the owner first. So we'll send the message get owner to the owner handler. That will return the owner object. If that owner object does not exist, that will be the end of the use case, according to the activity diagram that we were looking at a few moments ago. On the other hand, if the owner object does exist, then we can get the ID from the owner object and use it to send a message called getOwnersPets to the pet handler. The pet handler will then consult its collection of pet objects, and for each pet whose owner ID matches the one that was passed to it, that pet object will be passed back here. Which means then that when we come to the view part of this, we'll be able to get from the owner object the various details, and then for each of the pet objects, we'll also call getDetails. And so we now have an idea of the kinds of classes that we're going to have. We've seen in the analysis model here that there will be a boundary class. We understand that it's going to consist of a controller and some view classes. We also see that there are some model classes, owner handler and pet handler, owner entity and pet entity. So understanding this, we can now consider what kind of view components we're going to have. This will help us to break down that boundary class into a little bit more detail. A good way of doing this is to consider the page navigation that will take place. We're going to start at the welcome page, the index page, and there will be a command called view all pets that will move us into the view all pets.jsp. From there, we can send a command called view owner, and in return, we'll get the view owner.jsp. We could then go back to view all pets, or we can come back to the home page. We might also go from this view owner page to the view owner pets.jsp by issuing the command view owner pets. So those are the three pages, the three views that we're going to have in our system. And so those three views, when combined with the controller and the model components, will form the internet application. We'll look at the code for those a little bit later on. If we now consider the class diagram that comes out of the analysis model, we'll start off by looking at the pets controller. This is going to be a servlet because this is a Java-based internet application. And so there will be these methods, do, get, do, post. We're developing this in NetBeans, so we're going to have a process request method. And for each one of the use cases, we're going to provide a method whose job will simply be to control the interaction between the model components that relate to each request and the view components that relate to that request. Now, in the exercises that you've been doing so far, every single model component has been a servlet. But in this case study, I've decided not to use servlets for the model components, but to use plain old Java objects, POJOs. And so the only servlet in this case study is going to be the controller. The analysis model showed us that we would need a pet handler and an owner handler. So these are going to be two separate classes. According to the analysis model, the messages that are passed to owner handler and pet handler include, for example, getOwner and getOwnersPets. And so we will find that there is a method in the owner handler called getOwner and a method in the pet handler called getOwnerPets. So you can see that the methods that we're putting in here will correspond directly to the messages that are listed in the analysis model. Now this is good practice because it helps us to relate the parts of the class diagram with the parts of the analysis model that have inspired this bit of the class diagram. And it helps us to ensure consistency between the various models. We also saw that the pet handler was going to maintain a collection of pet objects. This is where we start to think about our solution in terms of how it's going to be implemented. If this was simply going to be entirely memory-based, then we would probably have inside the pet handler class a collection, such as an array list, of pet objects. But in this case study, we're going to use a database. And so this model is going to be responsible for interacting with the database. Now, knowing that I've got two classes, both of which are going to interact with the database, I decided to extract the commonality from there into another class called a database manager. And in the database manager, I'm going to have methods to establish and release a connection with the database, a method to prepare a statement based upon an SQL string, and then methods that will allow me to set parameters within that prepared statement before executing the prepared statement and then getting the result set if it's a query, or getting the update count if it's some other non-query statement. And so the pet handler will have a reference to the database manager, and these methods, the getAllPets and getOwnerPets methods, will use the database manager to query the database to extract the information that's required, and then we'll build some collection of the objects that have just been extracted from the database. Now I'm doing this as a pet object, which is going to be a data transfer object, DTO. For each column in the database, I'm going to have an attribute with a constructor that will allow me to build the object based upon those values that I've extracted from the database in the get method. And later, the view page is going to use these get methods to extract the information from these attributes. So the model is going to extract from the database the data, put it into the data transfer object, store that as an attribute on the request scope so that the JavaServer page can then access these objects, get the information, and display it for the user to see on the web browser. And so that's the class diagram. If we wanted to, we could then go on to describe the communication from method call to method call by using a sequence diagram. But given that this is a fairly simple application, I've not bothered to do that. So our next job is to write the Java code from this class diagram. Each one of these classes will figure in our application, and what I've done in the source packages is to subdivide it by providing other packages, beans, model, and servlets. In the servlets, there's only the controller. In the model, we've got the two handlers and the database manager. And in the beans, we've got the data transfer objects. In the controller, the process request method is going to receive the command, extract it from the request, and then examine it to see what kind of command has been sent. ViewAllPets, ViewOwner, and ViewOwnerPets are the ones that we're expecting, and the corresponding methods will then be called and will control the response to that request. So for ViewAllPets, for example, we'll create a new pet handler object. From that object, we'll then call getAllPets, which will establish a connection to the database, prepare the statement using this constant, which has been defined up here. There is the prepared statement. You'll see that for getOwnerPets, we have a parameter that's put in there. And then having prepared the statement, since there are no parameters for getAllPets, we can directly execute the prepared statement. And if that gives us a successful result, then we can get the result set, build the array list, iterate through the result set, and extract the owner information and the pet details, adding each one to the list, and finally, having processed the result set in its entirety, to set as a request scope attribute the list, calling it allPets. When control comes back into the controller, all it has to do now is to set up a request dispatcher to the JavaServer page that is going now to process that collection of pet objects by using a forward. ViewAllPets.jsp has the HTML for displaying those pet objects. You can see at the top here that we have got from the request scope the attribute called allPets, storing it as an array list of pet objects in an object called list. This is in a scriptlet that we're importing with these page directives, the array list class and also our pet class. And then setting up a table with a row of table headers. And then in the for loop here, we're processing each pet in the list. And for each pet, we're creating a table row using the information that we obtain from get methods. So you should now examine the rest of this code to see how it all works together.